So what is it that happens? Well, this is the interesting thing. It's not a thing that happens. This is why it's taken people so long to understand the problem on its own terms. It's a thing that doesn't happen. This is why I refer to it as technical neglect. Neglect of any form is not a thing that happens, it's a thing that doesn't happen. That's why it's hard to see. You're looking for something that is not there. Okay? We normally think of, effects come from a cause, an action. So it's a thing that is not done. That's the cause that we're looking at. And we don't notice it. And we should ask the question, why is it that we're not doing these things? And how do we get better at seeing them? So let's talk about it from another point of view. Here is a boat. I honestly can't remember where I took this photograph. Clearly it was next to a large body of water, so I think we're fairly safe with that. Oh yeah, we're in Sweden at the moment. That's water. I looked out earlier, it's just ice. This is the liquid form, okay? Just so you're familiar. It's coming in spring. And we're going to solve, I'm going to give you a small problem here. You're in this boat, and you discover it's got a hole in it. Maybe it's got a lot of holes. You're taking on water. The boat is flooding. And we're going to solve this two different ways. We're going to solve this first as software developers, and then as the rest of humanity. We're software developers. Oh my goodness, we are taking on water. The boat is filling with water. Well, there's going to be a bunch of people busy raising JIRA tickets, but that's a separate question. What we're going to do is we're going to get really good at emptying the boat. I see the effect. Okay, we've got to fix the problem. You're not fixing the problem. You're fixing the symptom. You're fixing the effect, not the cause. Yeah, sure, you need to address the fact that a boat full of water is not very good at floating. But there's a deeper problem. You are taking on water. And no matter how good you get at emptying it, you are still taking on water. This insight came to me a number of years ago when I'd run a couple of workshops for companies on what to do with your legacy code, how to address your legacy code. And we did all the right things, and I think I said all the right things, and they did quite a lot of the right things, in particular in one case. It looked like we had a plan, and it looked like they were going to follow through. And then a few years later, hey, we've got legacy code problems. It turns out you have to learn how not to create legacy code as well as how to deal with what you have. You have to learn how to stop creating new legacy code, otherwise there's not as much point. So let's put this another way. Back before we had the vocabulary of technical debt, what were the ways we talked about it? Well, we didn't really have a proper set of terminology. Most people hadn't appreciated the underlying problem that happens with any code base and how complexity can emerge out of apparent simplicity. People underestimated this. They thought, in fact, many people still do, they thought of software development as projects. It turns out that this has been one of the most disastrous metaphors, or rather, disastrous pieces of vocabulary that we've ever had. A project is a thing, it's a finite game, it's a thing that has a bounded end and a well-defined end condition. That's not most software development. Oh, sure, software development contains projects, but most people work on products. Every now and then I bump into somebody who says, oh yeah, I've been with this team for years. Oh, so what are you working on? Well, this project's about 7 or 8 years old. Wow, that must be really unsuccessful. You still haven't reached the end. Yeah, 7 or 8 years, that's what it took to put humans on the moon. Okay, so you put humans on the moon, right? No. You're working on a product. It's not a project. Products are infinite games. They're unbounded. Yeah? If you design with product thinking, you choose a very different life cycle. Project management is almost entirely toxic to the things that we value and know are useful in software development. But we are reminded, I keep slipping up, I often say project when I mean product, but you're reminded every time you open up your IDE, it invites you to create a new project. Yeah, the vocabulary is deep. But back to this quote. This quote from Maya Manny Lehman, wrote this fantastic paper in 1980, which is very much in the rear view, okay? 1980, let's put some context. It's 44 years from now till 1980. 44 years back from 1980 was before there were even electromechanical computers and before wars had numbers. Okay? That's kind of the time span we're talking here. And he made this observation based on his work in the 1970s. It said, as an evolving program is continually changed, its complexity reflecting deteriorating structure increases unless work is done to maintain or reduce it. What he's doing is he's telling you that the very act of doing any form of development on an existing piece of code is inevitably going to cause some deterioration, even if you're doing a good job. Obviously, if you're not doing a good job, the deterioration is faster, so there is value in doing a good job. But what we're saying is the very act of taking something that works and changing something about it will have a negative effect in addition to the positive effect you're trying to introduce. Now, why is this? Why is this almost inevitable in anything that is complex? Well, it's almost inevitable because of a thing called focus, okay? A thing called attention. When you have focus on something, when you are focused on something, when you are paying attention to something, by definition, you are ignoring everything else. You cannot focus on everything, okay? That's not a thing, yeah? By definition, focus means not focusing on everything else. So you may be doing a fantastic piece of work here, but there is something that you will have missed in all probability. It might be a big something, it might be a little something. It might be a something you spot in 5 minutes. It might be a bigger something you spot in 5 weeks. It might be a far bigger something that your colleagues curse you for in 5 months, but it'll be something. It might be as simple as, oh, I should have renamed something. Or that piece of code is now dead because what I've just did renders it useless. Or this class should no longer be this class. It should be 2 classes. Or why do I even need a class at all? The point there is, once you zoom out, you start realizing the context has changed. Now, a lot of this is not surprising. It's just harder to see in an abstract space. And what is that abstract space? It's software development. In the physical world, we already know this. If I go to cook a meal, if I go and prepare a meal, I don't declare to members of my family, I'm going to the kitchen to make a mess. I mean, it would not be outside my frame of humor for me to do so, but that's not what I say. I go to the kitchen to make a meal. The side effect is there will be a mess, because that's what doing things in the real world always involves. There will be dirty dishes. Now, I could make a complete mess, or I can keep the mess kind of in check. I tend to keep the mess kind of in check, okay? I have a background in C and C++ programming, so I make sure I clean up as I go. Java programmers, they'll just let the dishes pile up and hope that, their parent will come along and tidy it up, until one day you realize you are the parent. But the point is, people have different philosophies around kitchens. But that's the point, is even when you're doing a good job, you're making a mess. And that's okay, because that is called the cost of ownership. That is the price of living in a physical world. It also turns out it's the price of dealing with any complex system. And we are not good at seeing that. He saw it. The structure will deteriorate, and he says, increase unless work is done to maintain or reduce it. You have to put work into the system to maintain order, in addition to the work for adding that feature, fixing that bug, doing whatever else it was. So here's an interesting word, maintain. It's the basis of the word maintenance. In software development, we have taken this metaphor and misapplied it a bit. We tend to use the word maintenance in software to mean fixing bugs. That's not maintenance, that's fixing bugs. That's product recall, that's a defect, that's different. That's not real world interaction that causes wear and tear. And let's be very clear, I'm talking about the code base here and the interaction with the developers. I'm not talking about the runtime. The runtime does not really suffer maintenance issues, and the source code on its own doesn't suffer maintenance issues. You don't find that, has anybody touched this binary? No, not for a while. When was the last time you ran this image? It's been a few months. Oh yeah, I'm looking at some of those ones have turned into zeros. It doesn't work like that. You don't look at a source code. You don't look at source code you haven't seen for a year and look at it and go, oh my goodness, the curly brackets have fallen to the bottom of the file, it's so old. That's not how it works. So the maintenance we're talking is the wear and tear that comes from actually interacting and changing that file. We also use the term maintenance to mean continued development. In other words, there's one team that normally goes around going like, hey, yeah, we developed the product, and then it's going to go somewhere else for maintenance, or what the rest of us call software development. Yeah? The majority of the life cycle is in that part. So we have the project, and then we actually have the product life cycle. So the point here is that we're misusing the word maintenance. I'd like to reclaim it, because maintenance is the necessary work we do for having the thing in the first place and interacting with it. So I've suggested, let's talk about metaphors, because I'm kind of a word nerd. I think language is fascinating. So I have a copy of the Oxford English Dictionary. It's one of the few things I actually still install from a CD-ROM. Obviously, I don't have nobody has CD-ROM players anymore, so we have one in the house. I always have to remember where it is. But this dictionary is almost entirely useless if your goal is to find out the meaning of a word and how it's used. Please don't use this. It's an etymological dictionary. It starts with the earliest definitions of the word, maybe 1,000 years ago, and then works forward. If that's not your thing, you will find this boring and misleading. If it is your thing, you can spend a lot of time in this book. But I'm just going to look at the word metaphor, given that I've used it. Metaphor, the figure of speech in which a name or descriptive term is transferred to some object different from, but analogous to, that to which it is properly applicable. It comes from the Greek metaphora, literally meaning transfer. What we're doing with a metaphor is we are creating a mapping, okay? And this is what we do in software a lot of the time. In the Poser 5 book that I co-authored a number of years ago, we made the observation that in software, the physical and invisible domain of software is more about metaphor than matter. If you think about the names of the things, the products that you use, but the classes that you write, you see it's all over the place. There's the desktop metaphor. There's a window metaphor, and the window metaphor gives you a vocabulary. It gives you a set of metaphorical entailments, a system of words. You can open a window, you can close a window, okay? We don't talk about starting a window or stopping a window. That's the language of engines. We do also use the language of engines and the metaphor of engines. We talk about running, software. Yeah, running is the language of machines and engines, as is crashing. So that you see, you create a system of you create a system of meaning. Now, obviously, it's not perfect. I don't know if you've ever tried to resize a real window. It's surprisingly expensive. Yeah, we've done that. So it's not perfect, and we're going to come back to this question of perfection and imperfection. But what we're doing is, if you think about most of the things in your code, there's normally something there, and it relates to something else. Whether it's the word network, whether it's manager. It also, by the way, tells you sometimes when you're overusing a metaphor. Yeah, a lot of code is very management heavy. You should know that's already a bad thing. But we are generally going through these things. We have all of this stuff. If you're a network programmer, the very word network is a metaphor. Ports and sockets, yeah, that's totally that. And then, what about architecture? Oh, let's play with ports and adapters. And layers and all the rest of it. We go through. Everything we name on the inside of the code base comes from the real world, because we need something familiar. We take that in there and we say, it's like this. So we do that. And the observation that was made in this kind of classic book, in fact, you can tell it's a classic book because nobody produces book covers like this anymore. 1980. That feels like, it's got that slight post-1970s feel. Metaphors We Live By George Lakoff and Mark Johnson. Some really interesting stuff here, because they basically said, metaphor is fundamental to the way that we think. It is not simply about poetry and poetic language. The essence of metaphor is understanding and experiencing one kind of thing in terms of another. And that's what we're doing, it's a mapping. We're basically saying, particularly in the world of software, here is an abstract idea, or a complex idea, or an idea that is new to you and unfamiliar. And what I'm going to do is I'm going to take something with which you're already familiar, and I'm going to say, you know this, and you go, uh-huh, and I say, right. It's kind of like, understand this in terms of that. It's a mapping. It's obviously a partial mapping. It's not perfect. By definition, no metaphor can be perfect, because otherwise it's not a metaphor. It's the thing itself. But that's how we do that. And we do that everywhere. And we do that in the very basis of our spoken language. It's how we use prepositions. You can even see people doing this on a daily basis, taking photographs. Here's a picture of me in front of tourist attraction. Guess what? That tourist attraction doesn't have a front. Yeah? Here's a picture of me in front of the mountain. Mountains don't have fronts. That's not a thing. People have fronts. We're saying, you know how human beings work? We have front, we have back. Yeah? I'm going to use that language and that structure. It informs everything about how we think. It's so deep we don't even notice we're doing it. So we do need to evaluate, though, what makes a metaphor good? Because we know a metaphor can't be perfect. So, by the way, if anybody ever criticizes a metaphor and says, oh, that's not perfect, then that's not a criticism. But metaphors can be better or worse. So there are 3 points to consider. And I wrote a piece for O'Reilly Radar a couple of years ago on exactitude and technical debt that explored exactly this. To be considered good, a metaphor has to offer a number of points of useful correspondence with what is being described. We're saying, see this thing that you're not familiar with, and this thing you are familiar with, there's a lot of points here that relate to that. It also informs the language that we use. Great, so we can start understanding this in terms of that. Another really important point is there shouldn't be too many points of contradiction. It won't be perfect. So, hopefully the contradictions won't really be central. Because if they are, then this is not going to work out very well for us. And then one that is deeply context sensitive and tells you about your audience. Because sometimes you can have 2 people with different backgrounds, one saying, oh, this is a good metaphor, and the other one's going, no, it isn't. And then you realize they've got different backgrounds. Because to one, the idea is familiar, the other, it's not. And so therefore, it's not a good idea. Basic point. If I take a complex idea you don't understand, and I give you the metaphor, and you don't understand the metaphor, and then I have to explain the metaphor, that is a failed metaphor. Yeah, if I have to explain the thing that explains the thing, that's too many levels of indirection. And that is context sensitive. That is audience sensitive. That's why people respond differently to different sets of vocabulary and different concepts. Let me give you an example of this. This originated with Chris Matz. Steve Freeman did a really good write-up a few years ago. You can still find it on the web archive. The original site has gone. But there's a commentary on this one, summarizing it. This is Steve's original. Bad code isn't technical debt, it's an unhedged call option. How many of you know what an unhedged call option is? Yeah, this isn't going to work for you, is it? For people in fintech, this is a really interesting analogy. So, although I've worked in a bank, and I didn't work in derivatives trading or anything like that, it doesn't mean an awful lot to me. I have to have it re-explained every time. And then I go, oh yeah, that is a bit like that. But what I'm using is my understanding of technical debt to try and understand unhedged call options. It's the wrong way round. Yeah? But for people who do actually live and breathe this stuff, they go, oh yeah, this makes perfect sense. But it tells you that there's an audience thing. You have to know your audience if you're going to deploy a metaphor. I had an interesting conversation with somebody last year, year before, I don't know. These days, the years kind of do funny things. Everything since 2020 has been kind of reordered and strangely blurred. I think it's like months are now kind of ordered by a hash dictionary rather than a tree map, But somebody said, oh yeah, they work in the medical sector. And they had an alternative metaphor, which they had to explain to me. And I said, oh, okay, yeah. But for your crowd, that's going to make a lot of sense. So it needs to be familiar. So let's go back to the dictionary and explore another of these words. The word legacy. The curious thing about legacy is that we've taken in software something that is normally by default considered positive. In English, if you say legacy, it means something good unless you put another word in front of it, like, oh, it's a bad legacy. Okay, but by default, legacy has a positive connotation. Trust software developers to take that and, oh, let's invert that. Because we invert everything else in software. Yeah, we got trees. I remember telling my kids, oh yeah, in software we have trees. Oh, do you? Yeah, the root is at the top and the leaves are at the bottom. And my kids thought, you are kidding. No, for real. No, it's a joke, Dad. No, it's for real. So we take stuff and we invert it. So we've taken the idea of legacy, good, and turned it into something bad. Now, when did we start using the term legacy? 1989. Now, your response to this, so this is actually relatively recent. Or is it? Well, your response to it depends on when you were born. If you were born after 1989, this has existed forever. It is eternal, like the universe. If you were born before 1989, you might be surprised. Wow, that's quite late. Okay? What did people talk about before that? Well, they just called it crappy code or just expressed themselves. Well, a friend of mine used to express it by smashing his keyboard. Very expensive developer to have in your company. But now we have words. We don't have to smash keyboards. Isn't that nice? And there is a definition here. Designating software or hardware which, although outdated or limiting, is an integral part of a computer system and difficult to replace. That's not actually a bad definition. There are lots of other definitions. One of the things I want to tell you is that there is not one unique definition of legacy that is correct, not even in the OED. I've run workshops on this because it's important to understand when one person uses the term legacy, they may be talking about something different to what another person is talking about. If one person may say, this is legacy, and they're referring to its code quality. Most people do, to be fair. I mean, I don't often hear people complaining about, oh my goodness, I'm working on this legacy system, and the code is so clean and so elegantly architected, oh, I don't know what to do with myself. That's not a thing. People don't use the term legacy in that context. Other people, legacy is we've lost the knowledge. We don't know why it is this way. It just is. The people who developed it, they left the building. The technology that it's based on, that's dead. That's no longer supported. We lack the expertise. They're describing a loss of knowledge. In other cases, it's an intrinsic quality. It's a bit of a mess. In other cases, we are describing something that has other qualities about it, and those are causing us some amount of discomfort, pain, or cost. So there's a nice definition that I stumbled across recently from Angel Sierra. Legacy code is often defined as code that makes more design decisions than the team working on it. You know, I hadn't actually come across that phrasing of it. And I Googled around for it. I couldn't find the original source, but I thought, you know what, that is a lovely way of putting it. That is a brilliant way of putting it. The idea there, the code is making more decisions than you are. You know, if you want to imagine your code base as an active participant and stakeholder in your team, just imagine the meeting. Okay, team, we're going to do this. And the code base is sitting there going like, no, you're not. Oh, no, that's not easy. No, it gets this veto, this power of veto. Yeah, we're going to be agile. The code base is looking at you, oh, no, you're not. Have you seen the state of me? Okay, so the point there, it's an active stakeholder. You've got to respect it. But it also tells us something about the processes that grow up outside the code. You cannot just consider something intrinsically. You need to look at the things that are outside it. The process, the way that people interact and deploy the software and how they respond to it. Could we define a legacy process as one that makes more decisions on how a team functions than the team itself? I like that. So let's talk about this kind of costing effect. Now, there's a bunch of articles and studies out there. I just kind of picked this one because it gives us a bunch of numbers. The numbers vary from article and study to study. They're all fairly horrifying, so that's good enough. Over $1 trillion to keep the lights on. You know, back in the days, there was a time when people didn't even have to worry about what trillion meant. Trillion was like zillion or gazillion, but now actually we have monetary values that go with it. Legacies drag on productivity. In 2019, a US Government Accountability Office report found the federal government spends more than $100 billion on IT and cyber-related investments annually. Okay, that's a lot. Of this amount, agencies have typically spent about 80% on the operations and maintenance of existing IT investments, including legacy systems. Okay, now the numbers are getting big. When we look at the proportions elsewhere, on average, 31% of an organization's technology is made up of legacy systems. Now, of course, we need to be careful with the term average. Things are not evenly distributed throughout the software space. There are old companies with deep legacy and young companies who are just creating exciting new legacy. That figure of 31% still feels quite low. Is that something to worry about? We're saying, around a third of your software is legacy. That doesn't seem like a critical problem. Yeah, that's the wrong way to look at it. You're looking at the quantity of stuff, not how much it costs, which turns out to be, a lot more. So maintaining those systems can be a costly burden, an average of 60 to 80% of IT budgets. So you're looking at around 1/3 is costing you 2/3 or more. Oh, okay, now we've got a definition of legacy that we can take to the finance people, okay? That's a definition of legacy. This stuff is costing us. It is costing us progressively more and more, no matter what we do with it. We own it, we're interacting with it, and it's a drag, literally a drag. Legacy technologies hamper efficiencies and restrict growth in an estimated 88% of businesses. So this is about 7/8 of businesses are experiencing friction in their development. We want to go forward, yeah, but the past is calling you back. The past is holding you back. Funnily enough, that's actually a figure that is surprisingly close to one of my optimistic estimates of, in a given day, a typical developer, in an 8-hour day, a typical developer is spending 7 hours fighting the past and 1 hour actually working on the future. And I remember telling this to one client. I said, it's informal. This is anecdata, not actual data. But I said, on a good, and they kind of looked horrified. And I said, and that's on a good day. So Adam Thornhill's in another room, so I'm going to plug the second edition of his new book, Your Code is a Crime Scene, is now out. I wrote the foreword, so I'm biased, therefore you need to know my stake in this. But yeah, no, it's a good book, because I've been plugging that book since it first came out. Adam and colleagues, Marcus Borg and Anis Monis, recently published this white paper, Refactoring versus Refactoring. Honestly, one of the best titles I've seen of a white paper for a while. Advancing the state of AI automated code improvements. Yes, I'm going to mention AI because are you even doing a talk in 2024 if you don't say something about AI? Okay? But what I want to do is try and bring a different perspective on it. Not the individual perspective. I want to bring you the statistical perspective. What happens when we roll this out across the industry? What happens in typical cases? And there's a nice innovation that they introduced. We introduced a novel innovation for fact-checking the AI output and augmenting the proposed refactorings with a confidence level. Now, what's interesting here is that they're creating refactorings, and they looked at a variety of LLMs, and the performance was not great out of the box, as we'll see. But they added a fact-checking layer. This is the one thing often people tell you when you are interacting with an LLM, is you need to have a separate source of reality to just ensure that it's not bullshitting you. Yeah? The LLMs will answer you with like conviction and confidence. I tend to liken them to sociopathic, people-pleasing savants. They know a lot, they want to please you, and they don't care about anything. And it's, yeah, I'll lie to you. I'll make stuff up. That's okay. I will deliver you lies with the same kind of confidence and punctuation as the truth. It's up to you to decide. Yeah? And they said, by rejecting incorrect solutions, 98% of the remaining AI-generated refactorings improve the code while retaining the original behavior. Okay, so in other words, they've decided to harness the idea of generating set-based solutions and then check them. Do a reality-based check. The problem is, out of the box, not so good. In fact, with the best performing model only giving a 37% probability of success, it's more likely that the attempted refactoring will break your code than not. 37% success on a refactoring is disastrous. If you have a developer who is working at that level, you need to go to them and say, hey, is everything okay at home? You know, are you good? I mean, do you need to take some time off? Like maybe forever? Maybe you move to another industry? 37% is horrifically bad. So, yeah, you need fact-checking. Now, we might hope that this is going to be a way out of things. And there's this kind of question of, remember the boat? Remember that refactoring is part of the story to try and get us out of it, but you've still got to deal with the hole. The hole's coming in. Why is there water coming in? We're creating legacy code. Okay, but let's also understand. So I posted this on Mastodon last April. My observation back then, I didn't expect to be proven correct so quickly, by the way, as I'll show. The practical consequence of using LLMs to generate code is many developers will find they have unwittingly moved themselves into a role they were probably trying to avoid. They have automated the creation of legacy code and have redefined their job role as debugging and fixing such code. I'm going to take one of the bits of my job that's fun, and I'm going to get something else to do it. It's going to generate code that I don't fully understand, and now I've got to fix it. Now, I'm not saying that's going to happen for everybody. I'm just going to say it's going to be the majority. And it turns out I was right. This report came out recently, and of course there needs to be further study, but I did not expect to have this happen quite so quickly. Coding on Copilot. 2023 data shows downward pressure on code quality. Good grief, Copilot is, I mean, if Copilot were a child, it would only just be walking and speaking. And already we're seeing evidence of code quality taking a nosedive. Now, I'm not saying this is true for all developers. Remember, this is how statistics works. For some developers who know what they're doing and know how to interact with a tool and know how to review what they're getting and understand their relationship with what is being generated. And Henrik put it in his talk about you still own the software quality, and they understand that. Those people are absolutely having a great time with this. But everybody else is just slowly pushing the quality down. The observations and the trend forecast is this is not going to get better. We find disconcerting trends for maintainability. Code churn, the percentage of lines that are reverted or updated less than 2 weeks after being automated, is projected to double in 2024 compared to 2021. Specifically, we find that the percentage of added code, copy and pasted code is increasing in proportion to updated, deleted, or moved. In other words, we're just ending up with stuff being added in, and more of it. In this regard, code generated during 2023 more resembles an itinerant contributor prone to violate the dryness of the repos visited. This is in response to, they posed a question in this study. Their question was, is using Copilot, and perhaps we can generalize to any form of AI assistance, is it like having a senior developer who is a part of the team, part of the organization, vested in the architecture and the people, is it like having one of those help you, or is it like having a short-term contractor? It's like having a short-term contractor. Lots of them. In other words, we're already seeing this effect. Now, what this tells us is something that we already knew. The problem is more to do with our understanding of how we use tools. Here's something I posted a couple of years back. One of the great things about languages with modern IDE support is that thanks to refactoring tools, legacy code is a thing of the past. Unlike with older languages, developers never have to experience long methods, rambling classes, poor identifiers, or complex logic. I mean, it is so cool living in the 2020s. We have none of those problems. It must be an absolute delight to work where you work, because I remember these were always problems in codebases I saw, but we solved this problem 20 years ago with the initial widespread adoption of automated refactoring. These are solved problems. 80 to 90% of the code smells that people complain about are solved. Straight out the box. You just click, done. And you don't have to experience that anymore. Yeah, guess what? The problem wasn't the tools. It turns out most people don't use refactoring tools. Oh, they rename. Occasionally they extract a method. They might move a couple of things around. But it turns out the tooling wasn't the problem. If you don't know what you want from something, and you don't know what good looks like, and you don't have a culture that supports you in improving stuff, I can give you the most amazing tools in the universe, and it's not going to make the slightest bit of difference. In fact, it's going to drag you backwards. That's the thing. The differentiator is that some people are going to people who really understand how to use the tools. And this is a story we keep seeing every few years. People who really understand the tools know what to do with them and get a real effect. The people that don't create problems for themselves. You can think of almost any tool. I used to work with a guy who was dyslexic, which in the English language is disastrous from a spelling point of view. And I remember we were trying to put together some presentations, and I was going through his presentations like, Selvin, man, you've got to use the spell checker. He says, I have. And I said, but what's going on here? He says, yeah, some of the words, I just put them in the dictionary because they looked right to me. So now you have a polluted dictionary. He's made the dictionary worthless. And he's created more work for everybody else in having to do this. It happens with dictionaries. It happens with architectural ideas. Remember years ago I gave a particular team a particular way of implementing a state model. And I just showed them. I passed them a paper that I'd written on it. I said, look, here's how you implement it. I said, you guys can be done with this, and this is really great. 2 people pair programming on this. The test, you'll be done within a few days, and that will reduce this otherwise complex state model to something really simple. And I was coaching this team. A couple of days later, I went in, and they say, yeah, that's a great technique, Kevlin. Yeah. I said, okay, so who have you got on it? Oh, the whole team. What do you mean the whole team? It's for 2 people. Oh, no, we've divided it across 8, and we split it up, and we're going to spend the next 3 weeks doing it. No, it's 2 people in 1 week. But somehow they've managed to scale it, that word, scaling, yeah? So you can give people something, and if they don't understand it, or they have a culture that doesn't support that understanding, it's going to work out negatively for them. I would have been better off not introducing them to that technique. So we have this kind of difficulty. So let's talk about things like legacy. We use this term legacy. We use the term spaghetti code. That's not a metaphor, that's a visual parallel. Spaghetti is tangled. It's not a metaphor because people get excited by the whole pasta approach. The minute you say spaghetti code, no, you want lasagna because it's layered. And it's like, well, hang on, you're telling me that spaghetti is bad and lasagna is better? I disagree. I'm a long-time spaghetti supporter. I prefer spaghetti to lasagna, and I will fight anyone that says otherwise. But it doesn't work as spaghetti bad, lasagna good. And what I love is every generation rediscovers ravioli. Lots of people around going around, oh, ravioli, that's microservices. And it's just like, yeah, it's microservices. Before that, it was services, which curiously are smaller than microservices. Clearly, micro means something different to what I was taught when I was younger. And then, it means components, it means objects. Yeah, each generation rediscovers it and repurposes ravioli. Code rot and software decay, these are natural processes. They do have the suggestion of degradation with time, which is exactly what we want. This is a really nice metaphor. But the one discomfort that we have is the fact that this degradation is from nature. It's from outside. It is the case of the curly brackets fall off when you leave them. Yeah. The point is, if I leave yogurt in the fridge for too long, it becomes a biology experiment. But I didn't have to do anything. That's just nature. If I leave code for that amount of time, at least it's safe. We know it's in a known state. So it doesn't quite work there. Software entropy, I always used to think was really good. The first company I worked at, we liked the idea of the metaphor of the idea that you put work into a system to maintain its order. That works. That's great if you understand what entropy is. But it turns out that half the people in that company had degrees in physics. Explaining entropy and the second law of thermodynamics to somebody who has no interest in that is not useful. Technical debt, we'll talk about that one. Unhedged call option, we've talked about that one. Housework, we will talk about that one. So it originated with Ward Cunningham. Throughout the 1990s, the debt metaphor became used increasingly, but it really reached a point of inflection in the early 2000s, partly helped by Martin Fowler, talking about it on his blog. And he makes this point. Technical debt is a wonderful metaphor developed by Ward Cunningham. In this metaphor, doing things the quick and dirty way sets us up with a technical debt, which is similar to a financial debt. There's some really important words here. Similar to, it's not a financial debt. It's similar to it, but it's not a financial debt. It also helps seal the term technical debt. It wasn't called technical debt originally. It was just the debt metaphor. People variously call it quality debt, design debt, technical debt, but we now, we've settled on a name here. But perhaps one of the issues that we have is quick and dirty is a suggestion that it's not necessarily positive. It's deliberately imperfect, and hey, so what? We managed to do something. It's pragmatic. I'm putting pragmatic in quotes because half the time I see people using pragmatic, it's never good. Oh yeah, we're doing pragmatic agile. Okay, you're not doing agile, are you? Yeah, that's a fancy, we're doing pragmatic functional programming. Oh, it's not functional programming at all, is it? So when people often use the word pragmatic, it's just try using the word not instead and see if that fits better. Yeah? But in this particular case, there's a negative suggestion, and that's kind of been picked up on. So therefore, people often think of debt as automatically bad. Ward, when he introduced this in 1992, that wasn't his approach. He was looking at debt from a general finance point of view. Specifically, and perhaps we picked up the wrong term here, it's not really a debt metaphor, it's a borrowing metaphor. When you borrow something, you're supposed to give it back. Okay, that's the idea. And we've got very poor at the giving back bit. Shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with a rewrite. It's about a trade-off. There's something I can achieve now by taking on a little debt, and I can afford to pay the debt in future. Oh, I need to buy this month, but I don't have the money. I'll put it on a credit card. Next month, I repay it. If I don't repay it, then obviously that's a really bad move. I get interest rates on that. That's what he was trying to suggest. We can make trade-offs in time. We can make trade-offs because we're unfamiliar with the technology. We can either wait till we become perfect with this new technology, or we can try something, see how that goes, and acknowledge that we're going to come back with more understanding and repay that. We can try something that we know is incomplete, but it might at least interest the customer, and then come back and do a more appropriate version once they understand their requirements and we understand our requirements. So the idea is there's an intentional trade-off. The whole thing is it relies on the repayment. And he observes the danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. So we know that no metaphor is perfect, but there are two common ways in which the metaphor of technical debt is misapplied. The first one is that people often assume, technical debt, that's bad. Oh, Kevlin, we've got a lot of technical debt, but is that bad, I say? And they kind of look at me like I'm stupid. It's a trick that I learned with my kids. And it's a case of, like I said, well, you've told me you've got technical debt, but you haven't told me if it's, bad or good. And I say, well, technical debt's a bad thing. No, it isn't. We have debt for a number of reasons. Sometimes we have debt because we want to achieve something we couldn't otherwise achieve. Yeah, if you want to buy a house, then having a mortgage is a very useful way of doing it because you normally can't afford a house straight out. A mortgage is well structured, there's very few surprises, terms and conditions, and what do you get? You get a house, fantastic, that's awesome. The point there is that is a structured debt, that's not a bad thing, it'd be nicer to not have it, but it is not intrinsically a bad thing. The other way in which people screw up the technical debt metaphor is they make it a financial debt value. There are certain tools that will automate doing this wrongness for you. Some tools will tell you, your code base has this many dollars, this many euros, this many pounds of technical debt. And it will give you a precise figure. We have a name for that. It's called bullshit. This is bad science at its worst. This is pseudoscience. And I've had people say, oh yeah, but it helps us talk to the organization because we can give them a financial figure. And I say, yes, but it's still a lie. You're lying to your organization. I leave the morality as a question to you, how comfortable you feel about lying. But there is no basis in reality for that figure. You cannot calculate the actual debt by going around and seeing how much duplication you've got and adding it up. That simply doesn't work because you don't know the context of that duplication. Duplication in a piece of dead code, you can write off. Duplication that causes decoupling is a positive, not a negative. In other words, you have to have deep contextual understanding to do this. And then you have to know what the software lifecycle costs actually are. And then, in fact, none of these are related to the tool. So please don't make the mistake of doing that. So in this notion of misattributing effect and cause, what normally happens is we're dealing with unmanaged technical debt. Not just technical debt. What people are not saying is the most important thing, is we have a lot of debt and it is not managed. That's the bit that's important. That's your problem. Not that you have technical debt, that it's not managed. If you have if somebody says, oh, here's our technical debt, we've got it all nicely itemized, maybe it's in Jira, maybe we've got ADRs describing everything, and here's our repayment policy, this is how we do it. And our team's been very successful repaying technical debt for the last 8 months. You know what? You don't have a technical debt problem. You have a conference talk, okay? Well done. You have managed your technical debt. Technical debt is not the problem. Unmanaged technical debt is the problem. Because it causes all of these things. So that's the message of the technical debt metaphor, which is going to take us neatly into the question of neglect. It's not simply a measure of the specific work needed to repay the debt. Sometimes people say, oh, we have this much technical debt, and they estimate it in days. That's the repayment cost. That's not the debt. It's the additional time and effort added to all of your past work, the current work, and your future work. That's the debt. So where does housework fit into this? This is Yvonne Lamb's observation. My theory of tech debt is that housework is the correct metaphor for the thing we call tech debt. We can't use it because tech has been made up of people who don't do housework or manage housework being done. Spot on. And this figure, Isabella Beeton, she was a kind of contemporary, she died when she was very young, actually, 28, Victorian England. She was contemporary of Charles Babbage and Ada Lovelace. But people don't recognize her contributions to computing because her claim to fame is she wrote a book of household management and cleverly disguised software advice in it using the metaphor of kitchens. Cunning. There is no work like early work. Clear as you go. Muddle makes more muddle. Don't leave it for a big pile at the end. Not to wash plates and dishes soon after using makes more work. That's what we're talking about. It's the idea that effort against time, if you don't do anything, you end up with, guess what? It's an exponential curve. I'm sure we're all sick of exponential curves after the pandemic, but that's an interest curve. The idea is one thing we could do is every now and then say we're going to do a cleanup. This is a punctuated approach. But in this era of continuous everything, the idea is no, you're doing it continuously. It's like hygiene. It's like continuous clearing of your kitchen. The idea is that this is recognizing that there is a maintenance cost that you need to absorb and amortize into your regular cost of development. That's what this word maintenance means. So I will close with the thought that when we look at maintenance, maintenance itself is an action. But as I said at the beginning, we're looking for something that is not an action, an inaction. We are looking for something that allows us to understand this dichotomy presented by John Seddon, which is a systems thinker. And he split demand. In other words, why am I working? If I'm here in front of a screen, working on some code, looking at some code, why am I working? What is the cause for my work? What is the demand for my work? Well, value demand is what we want it to be. The ideal. It represents demands of the customers for the things that they want and are of value to them. In an ideal universe, we'd say 100% of our time should be value demand. Failure demand, not so much. Failure demand is demand caused by a failure to do something or do something right. In other words, we are not doing something or we are doing something wrong. How much work is spent dealing with that? An obvious example of that is fixing bugs. That's not value demand. There's something that's broken. Now you're working. But also sitting there trying to understand code that is legacy code, trying to understand the incentive of unrepaid technical debt. You're sitting there scratching your head. The knowledge has walked out the door. You are trying to recover knowledge. That is failure demand. It has no value to the product at all. So this leads us to neglect. What we have done is not done something. Neglect is this absence, want of attention to what ought to be done. And if we look at, this is a pie chart that is quoted in that refactoring paper. When we look at how we spend our time, and by the way, there's lots of different pie charts around the industry based on different surveys as to how we do it. But generally we find that what we're probably not doing, we're spending a lot of time compensating. Most of that understanding is not understanding of a new problem. It's understanding of old stuff. So when it comes to dealing with neglect and addressing this and understanding that what we need to do is have a slightly higher awareness of the work that we are doing, and importantly, the things that we are not doing. The things that are invisible to us but actually cause us future work. In other words, accidentally create failure demand. And it's not because we don't know these things, it's often because we can't see them or our culture does not, our environment does not support us doing them. And there's no point in just saying, oh, we'll repay it one day, or we'll start next year. By the way, next year's already arrived, even though it's February. I'm going to still say we're still in the new year. It's now. Yeah? As the author Annie Dillard observed, how we spend our days is, of course, how we spend our lives. Thank you very much. Give me a round for questions and drinking for questions.